Hi everybody, I'm back. This is Professor J, and we're going to do a derivative, this time using what's called the quotient rule. And I'm going to call this the quotient rule 1, first video, because it's going to have more basic examples, and the quotient rule video number 2 will have more difficult examples that include the chain rule. So, if I have a function that looks like this, where u is an expression of x and v is an expression of x. I have a quotient, right? A quotient is division or a fraction. And I want to find the first derivative of this quotient. So I want to find f prime of x. The formula, the rule says it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now again, it's the same thing. I'm going to make you guys repeat that at least 3 times so that you memorize it. Okay, we're going to say it twice together. The first derivative of a quotient is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. It's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So let me show you. This will be my first example. And an example, a nice little basic kind of scenario. How about that? I have a quotient. G of x is a function, is equal to 2x over 3x squared minus 1. Okay, so in this case, my u, if I compare it to the formula, is 2x. And my v, if I compare it to the formula, is that 3x squared minus 1. And I want to find the first derivative, g prime of x, of this quotient. Okay, so we're going to say it out loud again. And then as you say it, I'm going to write it down. It's the bottom. Copy it down. Times the derivative of the top, and the derivative of 2x is just 2 minus. Let that go ahead and organize itself. Minus the top, which is just 2x, times the derivative of the bottom, which is just a 6x. All over the bottom squared. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And usually after I write it out, I go over it again in my head. I say it again in my head just to make sure that it all is correct, because I don't want to go ahead and simplify the wrong thing. Now the thing about the quotient rules, you have subtraction, so you're subtracting this whole second thing here. The nice thing about this one is that it's only going to give me one term when I multiply that 2x and that 6x, but if it was going to give me more terms, that negative, that minus, will have to distribute. So I'll show you that in my next example. So let me simplify this one. That 2 is going to distribute here to simplify the first case, 6x squared minus 2 minus 2x times 6x minus 12x squared all over 3x squared minus 1 squared. And that bottom I'm leaving factored because if at the end it will simplify, it's easier to deal with that when the bottom stays factored. Alright, and then I simplify 6x squared minus 12x squared is negative 6x squared minus 2 all over 3x squared minus 1, the quantity squared. Here is my first derivative using the quotient rule. The only thing that I might do, depending on your professor, depending on your teacher, is on the top I could factor out a negative 2, right? And then I have a 3x squared plus 1. If I were to distribute that through, it's the same thing. Divided by 3x squared minus 1, the quantity squared. And as you can see, if these were similar, if they were the same, then I could cancel one of them, but they're not, so I'm done. But this is also why I leave the bottom factored, because at the end, sometimes you do get a situation where you could, let's say, cancel something. Alright, so let me show you a more difficult situation. Here's another example. And in this one, I'm going to include a few terms that I'm going to subtract in that process before I simplify. So I'll show you what I mean. Let's let this function be what 3x squared plus 5x minus 1 over, I don't know, 8x to the third minus 2x plus 3. So boom, you have a quotient. Division, you have expressions on top and on the bottom. This is like my u, right? That whole 3x squared plus 5x minus 1. And this is like my v, if I want to compare it to the formula. But I'm going to say it out loud again. When I find this first derivative, I don't really need to know u and v. I could just say it as the bottom, copy it down, times the derivative of the top. The derivative of the top is just 6x plus 5. The bottom times the derivative of the top minus the top, copy it down, times the derivative of the bottom, which is a 24x squared minus 2. All over the bottom, just copy it down, squared. The bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom, squared. So it looks good to me, and now I have to simplify. Okay, so this is obviously a little bit more difficult when simplifying because I have a trinomial here, a binomial here, a trinomial, and a binomial. So I'm more than a FOIL situation. Each one of these terms has to distribute with each one of these, and the same thing over here, and this negative has to distribute. So I'm going to show my work to make sure that you guys understand what I mean by this. When I multiply these two terms, I'll start with the 8x to the third. This guy is going to distribute to these two terms here. So 8 times 6 is 48x to the fourth. 8x to the third times 5, 40x to the third. Now I distribute this negative 2. Negative 2x times 6x is negative 12x squared. Negative 2x times 5 is negative 10x. And now this 3 is going to distribute. Plus 18x plus 15. Okay, that's just the first, the first product. Now I have to multiply this second thing here. And I'm going to put parentheses around this first product because I want to take this whole thing and I want to subtract this whole next thing that I'm going to get. So the idea is that you recognize that negative has to distribute into whatever's left here. So now let's do the same thing. The 3x squared is going to distribute. So 24 times 3, or 3x squared times 24x squared is 72. X to the fourth. 3x squared times negative 2 is negative 6x squared. I'm not dealing with this minus yet, just these guys. So ignore that. Now that 5 is going to distribute. So 5x times 24x squared is 120x to the third. Leave a little space here. 5x times negative 2 is negative 10x. And finally, that negative 1 is going to distribute. Negative 24x squared plus 2. All over 8x to the third minus 2x plus 3, the whole thing squared. And just look over your work, make sure your signs are proper, make sure you have the right exponents on each of those x's. You didn't make any error because it would suck to kind of have to backtrack because we have a lot of stuff here going on. And it looks good to me. Okay, now this is the part that I was talking about. If this product gives me multiple terms, this minus from the quotient rule has to distribute to every single term there. Okay, so I mean, I could technically skip this step if I'm really good and distribute the negative and multiply this out, but I don't want anyone to mix their signs up, so I'm showing all my steps. So I'll show this step. I have a 48x to the fourth plus 40x to the third minus 12x squared minus 10x plus 18x plus 15, right? Then minus 72x to the fourth minus plus 6x squared minus minus 120x to the third minus plus 10x minus plus 24x squared and then minus 2 all over. I'm just going to say blah. The same thing. I'm not going to copy it down. Don't forget that denominator. This is me cheating a little bit. All right. Now I'm going to combine like terms, and I have a 48x to the fourth minus a 72x to the fourth, which is going to give me a negative 24x to the fourth. So these guys are done. Put a little tick mark to remind myself that I did them already. I have a 40x to the third and a minus 120x to the third. Any other x to the third? No. We get a minus 80x to the third. I have a minus 12x squared plus a 6x squared and plus a 24x squared. So when I combine those, I get an 18x squared. I have a negative 10x plus 18x, which is positive 8 plus a 10, positive 18x. And then finally, a positive 15 minus a 2, which is plus a 13, all over this 8x to the third minus 2x plus 3 squared. Boom. There's my first derivative. Good time, right? Again, this is a situation that does not include a chain rule, so this is actually a more simple kind of example. If you guys want to see a quotient rule including chain rules, then go ahead into the video, the quotient rule 2, okay, which I'll link in here, and I'll show you some examples with the quotient rule including the chain rule. If you need to see more examples like this, let me know. Go ahead and comment, and I'll put another video up there for you. All right, so on to the next video.